This is my audience. Imagine you had a website and you had to keep track of 1 million customers and their individual purchase histories. How would you do this without your system crashing immediately? This is where data structures come into play. But before we begin, a little about me. My name is Shim Patel, and I'm a computer science major here at Purdue University and a rising junior. My coursework deals heavily with data structures and algorithms, and I've also coded in multiple languages using said data structures. That includes C, C++, and Java. So I'm well qualified to discuss the topic. Today I'm going to be talking about what exactly data structures are, give a couple of examples, and explain why they're so relevant and important to us today. So firstly, what is a data structure? Well, according to a 2024 article in Tech Target by Scott Robinson, a data structure is a format for organizing, processing, storing, and accessing data. Think of it like a toolbox that stores individual tools for easy access. There are two kinds of data structures according to a 2025 Geeks for Geeks article: linear and non-linear data structures. The first structure is linear. Now, a linear data structure stores elements sequentially. So each object is right next to each other in memory and adjacent to each other. Think of it like a single file line. You have to wait for your turn to be accessed. An example of a linear data structure is the array. Now, the array is the most simple data structure out there. It's simply just a list that stores multiple elements of the same type. In order to access one element, you have to traverse through each element in the array individually until you reach the element that you want. And each element is accessed by the index. So say you had this array over here. This index 1 represents the first item in the array, of course. Then there's the nonlinear data structures. These are obviously not sequentially ordered. Think of it like a city map. Everything's there, but it's going to be all over the place, and it's not as easy to implement as linear data structure, but it's a lot more efficient on your memory. An example of a nonlinear data structure would be the hash table. Now, the hash table implements a key to element system. So you have the keys, and using a hash function, they take the keys and give each one a specific element, and an index. And that index number corresponds to the element that matches. So after this is implemented, you can simply just use the key for that element. You don't have to go through every single element in the table in order to access it. You can just simply go there and find it. Now, what are some examples of why data structures are so important to us? Well, according to a 2023 Medium article by Chineye Okeke, there are different uses for data structures, and it's prevalent through pretty much all of the internet and any form of technology you see. Take the two structures we just previously discussed, the array and the hash table. Arrays are commonly used in 3D development and 3D video imaging, because each array stores vertices of each pixel. And for hash tables are very important when it comes to creating databases that store large amounts of information that has to be accessed at a drop of a hat like that. And that's why hash tables are also very useful. Every data structure has a specific use, and it's up to you to find it. And no matter what you see on the internet, there's probably a different data structure used for it. And these data structures have given us a nice base to work off of to innovate and improve upon our existing data structures. There are several examples of this, and it's happened a lot more recently than you think. A 2001 study done by Edgar Chavez et al. Actually created a new data structure called the fixed queries array that made searches faster without requiring extra memory. Similarly, a 2011 study by Josh Triplett et al. From Portland State University, they actually devise an algorithm to dynamically resize arrays in order for them to be used concurrently by multiple threads without having each thread block each other. So what did we discuss today? What can you take away from today's lesson? First, we discussed what data structures are. Then we discussed two kinds of data structures, the hash table and the array. Finally, we gave a couple uses of these things, explained why they're so important, and how they're being developed and used in the future. I hope you guys learned a lot from today, and I'd like to thank you for your time.